Good morning, ladies and gentlemen. This is 6.3 area of composite figures. Trust me, finding the area of a composite figure is much easier than finding the perimeter. That's why we start with the area of a composite figure over perimeter. It is a little counterintuitive because we do teach perimeter first usually and then area, but for composite figures, it's backwards. Okay, and you'll see why at the end of 6.4. All right, let's move on. A figure that is made up of several parts, or several parts of a shape, is called a composite figure. So a composite figure is, a composite figure is just a figure that has multiple shapes combined to make one shape. So in order to determine the area of a composite figure, you might need to divide the figure into common shapes. Usually that's the very first step. Next, you determine the area of each figure separately, each shape separately, and then you add the areas together. And we're going to see this in example 1 and 2. Example 3, we actually have to subtract some areas, so that happens sometimes. So add or subtract the areas as needed. In this case, we actually have two shapes. If you're looking at it, you could think of it as triangles and rectangles, but there's actually just two. If we divide it right here, we have like a rhombus all the way out here. This will be our rhombus at the top. I'll call that area 1. And the bottom will be area 2. So area 1, to figure out the area of a rhombus, it is actually just A plus B times H all over 2. And that should be review of a rhombus. Area of a rhombus. You should know this already. If you don't know it, just go back through your notes. Make sure you have that chart, those charts with all the area and perimeter formulas, and you can use those as you work through things. Okay. We know the area of the top number is 12, and that's just found at the top there. And then the length of the bottom number of the rhombus is actually 15, because that's the length of the bottom number. And our height of our rhombus is actually just 6. And all over 2. So now you use bedmiss. You add what's in the brackets, then multiply, then divide. If you do the brackets first, you get 27, because 12 plus 15 is 27. It's 27 times 6, all over 2. So then you can use your calculator, multiply by 6, then divide by 2, and you should get 81. And because it's area, it'll be in meters squared. Okay, I'm going to switch up the pen color. Let's use red, because red is very obviously different from blue. So I'll recolor this as red. So area 2 here. Well, there's a few things. We know it's a rectangle. It's going to be length times width. However, we don't know what the width is. We know what the length is because the length is given to us. It's 15. You can see that very clearly. But I'm going to put it in brackets how we determine what the width is. Because the height from here to all the way down to here is 6. And this, from all the way up here, all the way down to the very bottom of our composite figure, is 13. It's going to be 13 minus 6. Now, if you're doing this in your head, you should already know that it's 7. So it'll be 15 times 7. So then you're left with 105 meters squared. So that's area 1 and area 2. Now we need to add them together. And to do that, I'm going to change my pen color to black. So I have A, so this is the area. You can put AT for area total, is equal to 81 which is area 1, plus 105, which is area 2. Add them together. You should get 186 meters squared. All right. So all you're doing is you're dividing the shape into two separate shapes and then finding the area for each shape within it. Okay, next question. Here we have two different shapes. I'm going to switch my pen color to blue. And we have a right angle triangle here. We have the triangle in blue. We'll call that area 1. And then I'm going to switch over to red because red's a good opposite color. Then we have a half circle, and we'll say that's area 2. Now, this will take a little bit of thinking on our part because we don't have a formula for half a circle, but we do have a formula for a whole circle. We'll get to that in a minute. Let's start with area 1. The area of a triangle, if you recall, is base times height divided by 2. Or base times height times 1/2. Either way, the math will work out. The base is 7.8. The height is 12. And that's just over 2. So then if you multiply this and then divide it, you should get 46.8 centimeters squared. Excellent. Next, we're going to take a look at the semicircle. So A2 is what I'll call it. And what's the formula for area of a circle? Well, if you recall, it's pi r squared. Now, we're not given r, so we'll have to say d is equal to 12, r is equal to d over 2, r is really just equal to 6. Okay, so there's our r value. So now we can plug that in. However, this is half of a circle. So what we're going to do is, instead of the whole area, we're going to divide it by 2. So pi times 6 squared all over 2. Don't forget those brackets. So now we're going to have pi times 36 all over 2. Now we'll get a decimal number. It should be 56.55 centimeters squared. Now I'm going to change the pen color over to black because we're going to find the total area. So the total area, or AT, is going to be 46.8 plus 56.55, which is just 103 point. Okay, so your final amount, your final area, is 103.35 centimeters squared. Okay, next example. This one's actually a little different. I'll use blue for the outside and red for the inside. Before we jump into that, determine the area of the shaded region. To determine the area of the outside figure, then we determine the area of the inside figure, and then we subtract the areas. Because the area of the shaded region that's all blue is actually just going to be the outside minus the inside here. I'm just going to make the inside there. I'm going to label it 2. And then I'm going to label the outside with a 1. I'm going to use blue because it is blue. So blue will be our outside, red will be our inside. That'll be an easy way to see. And then we will figure out our final sum of the area. Okay. So area 1, start up here, is pi r squared, right? Because that's the area of a circle, which we just learned, or reviewed. We're actually given r in this case, so we don't have to do any fancy division. It's pi times 10 squared So our final answer should be 314.16 centimeters squared. Okay, that's the outer area. If there was no inner area to subtract from, that's exactly what it would be. Now, if I change the color over, we'll work on the next area. So area 2. This is the inner part. Well, it's the same formula because it's also a circle, so it's going to be pi r squared. And we're actually given r for this as well. It's going to be 4. So it's going to be pi 4 squared. So pi times 4 squared is just 50.27 centimeters squared. All right, I'm going to switch over to black now, and we're going to figure out the final area. You could call it area shaded, or you could just leave it as area, and it's just area 1 minus area 2 in this case. So 314.16 subtract 50.27, and your final amount should be 263.89 centimeters squared. All right, and that's it for your final answer there and your final example. This should be enough for you to work on the composite areas practice. After you're done the practice, make sure you do the quiz. Do the practice first. If you're skipping the practice and jumping right to the quiz and you're not understanding the quiz, well, that's on you. If you're not understanding the practice, make sure you let me know, and I'll help you work through it. That's the whole point of that. And that's it for this lesson. Good luck with the next one.